What's up, people? We're going to do a little physics lab with this block of wood and this weight. I'm going to attach this spring scale right here to this block of wood. And when I pull this block of wood across the table, it will make the spring scale stretch out, and we'll be able to read a number for how many newtons of force it takes to get this block of wood to slide. What we're going to do is calculate the frictional coefficient, or the mu, of this block of wood against the table. Does that make sense? Now, here's my first question to you, because you've probably discussed the mu before. But if I have to pull on this thing sideways with exactly the amount of force equal to its weight, then what would the mu be? The coefficient of friction would be 1. If it was equally hard to pull it sideways as it was to hold it in the air, then my coefficient of friction would be 1. Now, before we calculate the coefficient of friction, the first thing we have to do is weigh this. We need to find its mass in grams and then come up with its actual weight, because its mass is not its weight, correct? Right, we can see the scale here. It says 0. Put the wood block and the weight on there, and we see that we have a weight of 597.9 grams. I jiggled this just a little bit and it changed to 598, so that makes it easier for us. So if something has a mass of 598 grams, my first question to you is, how much does it weigh? All right, let's calculate that. Weight is equal to mass times gravity. 598 grams is 0.598 kilograms, so that's our mass, and gravity is 9.8 meters per second. So the weight of this object is 0.598 times 9.8. The weight of this object is 5.86 newtons. That's how much that object weighs. The next thing we're going to do is try to move this thing. I've got a scale hooked up to it. I'm going to pull on the scale and get it to slide at a steady pace. Now there's two different mu's for this. There's two different coefficients of friction. One is the static friction, and that's the mu, or the friction for this object, from it being still to getting it to move. And the static friction is usually higher than the actual moving friction. So let's calculate the static friction first. If you look at the scale, I'll try to get down here closer for you. If you look at the scale, we're going to come up with a number. All right? Now let's come up with the number. Here's the newtons. It's that side. Before it moves. We're at 1.82, about 2.2. Does everybody agree with that? About 2.2. So this object weighed 5.86 newtons, and I had to pull on it with 2.2 newtons to get it to move. So the friction, the weight times the mu is equal to how hard you actually have to pull on it. Solve for this mu. This is the mu of static friction, and the word static is spelled like this, and static means still. This object is static right now. So the static friction of that block would be, we're going to solve for u. What would it be? 2.2 divided by 5.86. We'll take a calculator. 2.2 divided by 5.86. The static mu is 0.375, or we could round it off to 0.38 if we were being a little bit lazy. So there is the coefficient of static friction. Now the coefficient of sliding friction will be lower. In this video, we're going to take a look at what the scale says after this is already moving. I'm going to try to pull it at just a steady rate, and we're going to find the sliding friction of the object. So I've moved on down the table a little bit with the camera. I'm going to come by right here, sliding. And let's read the number. I'm reading 1.4 newtons as we go by. So we had this 5.86 newton weight. It's pressing down against the table with 5.86 newtons. We pulled on it with the scale, and we could read the number on the scale, and it was 1.4 newtons. So we had to pull sideways with 1.4 newtons of force on this. Here's our scale. We had to pull sideways with 1.4 newtons of force on this scale. So what was the mu? Well, we could say the weight, 5.86 newtons, times the mu is equal to the amount of force necessary to move the object sideways. Does that make sense? This is the coefficient of sliding friction because the object was sliding, and we're going to get a little lower number this time. So I want you at home to solve for the sliding friction. Okay, let's see if you got it right. 1.4 newtons. We've got to get the u by itself, or the mu by itself, divided by 5.86 newtons. See, the math is super easy. 1.4 divided by 5.86. The coefficient of sliding friction is only 0.24. The last thing I want to say to you is, what are the units of this? Like 0.24 watts. 0.24 nothing. It's just a number. It's just a scalar number. Newtons divided by newtons cancels out newtons. We just have this number. The mu is really just a percentage of the actual weight that can be applied to the surface and act as an opposing force. Only 24% of this weight can actually resist the sliding force in this direction. I hope you enjoyed that, and good luck.